And you've got a dog, so you understand how that works. Uh, and you know they eat stuff that we wouldn't touch, and they're fine. Um,
Absolutely.
yeah. Uh, it puts us in the hospital, and it's just lunch for the dog. Okay, now that in mind, bacteria growth. Okay, now bacteria do, uh, if they have enough stuff to metabolize, tend to grow exponentially. And they continue to grow exponentially well beyond the state where it really makes us sick. Okay? They even go beyond the state where it'll make your dog sick. But they don't get to the extent that it would make a hyena sick, because nothing makes a hyena sick. Okay? Apparently. Again, I'm not going to tell you the example because you wouldn't be able to eat for a week, but okay. So you have some bacteria, okay, and it's in your refrigerator. So bacteria at 40 degrees, that's kind of maximum refrigeration temperature. And it's not half-life. I'm going to say half-life, it's a doubling time. They both kind of feel the same to me because it's just a question of what sign you put on your constant. But at 40 degrees, let's say that bacteria double every 20 hours. Now that means in 6 days they would have had time to double about 7 times. Okay? So that 6-day-old chicken and rice that I ate, and didn't bother me, I know from experience, we didn't leave it out in the sun for a day or anything, but bacteria, taking a chance when you do that, and it hasn't caught me yet, but I should be more careful. Okay. At 40 degrees, bacteria double every 20 hours. Now, I don't know what bacteria that would be in what medium, or even if that's a realistic model, but let's assume it is. Okay? We start with two micrograms. Now, I don't know what 2 micrograms of bacteria would do to anybody, and which bacteria it would be. I don't even know if that's a reasonable number. But let's assume you got 2 micrograms. Which would be 10 to the negative 6 gram, a millionth of a gram. Okay? And let's say this becomes dangerous when you have .500 micrograms. Now, if you're trying to model this, you would really want to model by like micrograms per liter. Okay? 500 micrograms per liter, it's not an amount that I would tend to mess with myself. Okay? It just seems like it'd be a dangerous amount. So I'm not saying micrograms per what. Maybe it's micrograms per ton. Okay, and if you have 500 micrograms per ton, it becomes dangerous. Again, I don't know. I'm not a microbiologist, and I haven't looked up anything. Okay, so don't take this as a realistic model. Okay, anyhow, this becomes dangerous when the amount is 500 micrograms. Okay, so the question is, how long does that take? How long is it going to be before you have 500 micrograms? Okay, model. A of t equals a naught e to the kt. Now I could use b to the t here. You know, there's no reason I couldn't use a b to the t, but I'm going to stick with e to the kt because of the analogy with compound interest. Continuous compounding, it brings it into that context. Okay? Okay, so a of 0 equals 2 micrograms, and the way I'm going to write it this time, if it doubles in 20 hours, then a of 20 equals 2 times a of 0. We could say more generally, a of t plus 20 equals 2 times a of t. Okay, but that's a little more confusing, so we'll keep it this simple. This will work. Well then, a of 0 equals a naught e to the k times 0. And this equals 2 micrograms. So taking this much, we can say that since e to the k times 0 is 1, a0 equals 2 micrograms. Very easy to conclude that. Then a of 20 equals 2 times a of 0, and I'll do that over here. And it's not 2 times 4 micrograms, it is 4 micrograms. It's 2 times 2 micrograms because A0 is 2 micrograms. And A of 20 equals A0 e to the 20k, because if A of t is A0 e to the kt, and if t is 20, then we're going to have A0 e to the 20k. So A0 e to the 20k equals 4 micrograms, but A0 is 2 micrograms. So we have e to the 20k equals 2, dividing both sides by 2 micrograms, we get this. And now let's get over here so we don't have to worry too much about the watermark. Changing this to logarithmic form, and we get 20k equals the natural log of 2, so that k equals natural log of 2 divided by 20. Natural log of 2 is about 0.7. And this gives us k is about 0.035. So A naught is 2 micrograms. K is about 0.035. Now we have our model. So our model is now put the micrograms in here, 2 micrograms times E to the 0.035 T. And 0.035 is pretty close to 0, so I'll just mention that that's approximately equal to 2 micrograms times 1.035 raised to the T. It's like 3.5% interest. Okay? Now, how long does it take to get to 500 milligrams? Get A of t equals 500 milligrams. You solve this. And I say in milligrams, it's micrograms. And you have an equation that you can easily solve. And I'm not going to go through the details of solving it. I did on the last example. I'm not actually sure I did, but we know how to solve this. You divide both sides by 2 micrograms, and you get 250 here. And then you have e to the 0.035 t equals 250. And you then find that 0.035 is a natural log of 250. So I'll write this out. Okay, natural log of 250. And I can kind of estimate that. Natural log of 250 is about 8. And 8 divided by 0.035 means it's going to take a while. Okay? I said, I was basing this on something like 7 doubling times. Natural log of 250, if I calculate right, is between 7 and 8. I multiply that by 30, I get 200 and some hours. So I'm getting like 8 days when I do this. I was thinking it'd be around 7 days when I set this up. But something like that, okay? So that models if my chicken and rice gets dangerous at this level, and if this turns out to be like 8 days, then it's pushing it to eat the stuff at 6, because it's dangerous 2 days later. Okay? Still, with exponential growth, maybe I'm taking a calculated risk, but maybe I just shouldn't eat fried chicken and rice after 6 days, even if it hasn't hurt me before. Because the way exponentials go, there's one famous model of exponential growth, and that's a model if you've got lily pads on a pond. And if the number of lily pads doubles every day, and if after 20 days the pond is covered, how much of the pond is covered after 19 days? And the answer to that is, well, half, because every day it doubles. So that even though it's totally covered after 20 days, after 18 days it's only 1/4 covered. You're not worried about that until you notice the next day it's half covered, and then you think, oh, duh. Okay, well, anyhow, that's another example of exponential growth and worth thinking about.